Assalamualaikum. We are from group 5 and will be presenting the solution for problem number 4. Firstly, I will explain about the model and form of the given function. The model for this function is ISLM model and this function is in general form. Next, the endogenous, exogenous and parameter from the function will be discussed. The two endogenous variables from this function are y and y. Additionally, there are two exogenous variables in this function which is x null and m null. Finally, this function has no parameters. This is the diagram for the ISLM model. We will be using this diagram to prove our answer at the end of the slide.
Question 1. Find the total differentials of both equations. There are two ways of doing this question. First one is first way, that is general way. For the first way, we must give it a positive sign. And how to arrange it is just copy from the equation like delta f1 over delta I di plus delta f1 over delta x null dx null plus delta f1 over delta y dy equal to 0. And for the second one is delta f2 over dy over delta y dy plus delta f2 over delta I di plus delta f2 over delta m null dm null equal to 0. For the second way, which is specific way, you just copy the equation and put it in the bracket, but you must add d outside the bracket. So it will become like this, d bracket I star plus x null minus s bracket y I minus z bracket y I equal d null. So after that you have to expand all of this and you will get I subscript I d subscript I plus d x null minus s subscript y dy minus s subscript I d subscript I minus z subscript y dy minus z subscript I d subscript I equal to 0. Same goes to the second one. You have to expand and you will get L subscript y dy plus L subscript I d subscript I minus dm null equal to 0. Question 2. Find the total differentials of both equations by letting x null not equal to 0. Same like the previous question. For the first way, for the general way, you have to give positive sign for the equation like delta f1 over delta y dy plus delta f1 over delta I di plus delta f1 over delta x null dx null equal to 0. But for the f2, we don't have x null, so we just write delta f2 over delta y dy plus delta f1 over delta I di equal to 0. For the second way, we just have to rearrange the equation based on the first question. So it will become negative s subscript y dy minus z subscript y dy minus I subscript I di minus s subscript I d subscript I minus z subscript I d subscript I plus dx null equal to 0. Same goes to the second one, which is L subscript y dy plus L subscript I di equal to 0.
My name is Lavanya, matrix number 287483. The next step is rewrite the finding in step 2 into Jacobian matrix form. First thing we need to do is rearrange endogenous equal exogenous plus parameters. For the general way, the delta F1 over delta X naught times dx naught will be moved to the back because it is exogenous. For the specific way, we will move the dx naught to the back. Next, transform into Jacobian matrix form. For the general way, we need to find out each of the derivatives from the function given. For the specific way, we can directly transform it into Jacobian matrix form, and then find out the determinant of Jacobian. We use the formula AD minus BC, so negative SY minus ZY times LI minus II minus SI minus ZI times LY. After that, we need to find out the value of Jacobian determinant, either it is positive or negative. Follow the restriction given in the question. We found that the Jacobian determinant is positive. Step 4. Determine the effect changes in X naught on Y star and I star. So, we divide the dy, di, and dx naught by dx naught. And then, using the Cramer's rule to find dy over dx naught and di over dx naught, we will find both of them is positive value. With the ISLM graph, we can prove that our answer is correct. When export autonomous increase, income will increase as well. And when the export autonomous increase, interest rate will also increase.